Hi everybody, I'm Miss Cooksey, and today we're going to have our very last lesson on proofs. So today we're going to kind of round up our triangle proofs by talking a little bit about isosceles triangles and some of the theorems that go with those. So the first thing we need to do is talk about what an isosceles triangle is. An isosceles triangle is any triangle that has two congruent sides and a different third side. This is different from an equilateral triangle, which has three congruent sides, and a scalene triangle, which has all different sides. So the first theorem we're going to learn for isosceles triangles is the isosceles triangle theorem. This tells us that if two sides of a triangle are congruent, then the angles opposite those sides or across from those sides are also congruent. So if two sides of the triangle are congruent, then the two base angles are congruent. The converse of this theorem is also true. So if the two base angles are congruent, then the two sides of the triangle must be congruent. So we're going to use this theorem to solve two proofs. First, we know that WXZ, that larger triangle, is isosceles, and that XY bisects WXZ. That's our given information. So next, we know that WX is congruent to ZX. So let's put some tick marks there. So WX is congruent to ZX. And we know that because of the isosceles triangle theorem. So that says that isosceles triangles have two congruent sides. Next, we know that angle WXY is congruent to angle ZXY. This is because of the definition of an angle bisector. So it says XY bisects WXZ, so that means these two angles are congruent. I would also add another line that says XY is equal to XY because of the reflexive property. Then we know that the two triangles are congruent because of side angle side. So you can see our side angle side. This should have two check marks because it's different. Side angle side, side angle side. Let's look at one more proof. Here we know that MO is parallel to NP and angle 1 is congruent to angle 2. That is our given information. Well, if MO is parallel to NP, then angle 1 is going to be congruent to angle 3, and angle 2 is congruent to angle 4. These are corresponding angles. Now, because we know that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4, we can prove that angle 3 is congruent to angle 4. That is using the transitive property, using the information from step 1 and the information from step 2, combining it together to get angle 3 is congruent to angle 4. Once we know that angle 3 and angle 4 are congruent, we know that the sides of the triangle are congruent because of the converse of the isosceles triangle theorem. So in this video, we looked at a couple quick proofs using the isosceles triangles theorem, which says that in an isosceles triangle, two sides are always congruent and the angles opposite of those are always congruent. Thanks for watching. Hope this video is helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.